Augustin-Jean Fresnel was a French physicist known for his work on wave optics. Fresnel was born in 1788 in the northwest part of France, a year before the French Revolution began. His father was an architect, and both his parents practiced Jansenism, a Roman Catholic reform movement that said people couldn't do much to affect whether they went to heaven or not. This pessimistic view of human nature meant Fresnel grew up in a strict household that gave him the discipline he had throughout his life. Fresnel's parents taught him during childhood, but their efforts were not very successful, as he struggled with reading even by age 8 and showed little intellectual talent. However, once Fresnel went to the central school in Caen at age 12, he demonstrated skills in math and science. Deciding to be a civil engineer, he went to the Polytechnic School in Paris, and then the National School of Bridges and Highways. The Bridges and Highways Corps then hired him to work in the government departments of Vendée, Drôme, and Ille-et-Vilaine, building roads. During this time, he did light experiments whenever he could. An interesting thing is that Napoleon was trying to conquer France in this period. Since Fresnel supported King Louis XVIII and the rest of the monarchy, he lost his position when Napoleon returned from exile, which gave him more time to work on his experiments, even though he probably wasn't that happy about losing his job. But after the second restoration of the monarchy, Fresnel became a civil engineer in Paris, and later a secretary for the Lighthouse Commission. Fresnel was unusual in that most physicists at this time believed in the corpuscular theory of light, and he did not. This theory, corpuscular theory, by Isaac Newton, said light behaved as particles. Fresnel, on the other hand, believed in the wave or undulatory theory of light, which said light moved as waves. He was important because he provided much support for the wave theory using math formulas and lab work, and he developed a theory of diffraction. He also was the first person to prove that light waves have transverse motion, which means they can travel through a vacuum and resemble a sine function. To demonstrate light interference without diffraction for the first time, Fresnel used two black mirrors and showed that they had alternating dark and light bands. Later, Fresnel showed how people could get circularly polarized light, which means a type of perpendicular electromagnetic wave, as modeled in the pink picture in the corner. Fresnel also made what we call the Fresnel lens for lighthouses. They are still in use in some places today. When Fresnel made them, they worked much better than the mirrors people were flashing before them, since the mirror light became weak in storm conditions, and then obviously was not very helpful when people were trying to navigate through bad weather. The Fresnel lens is made out of many concentric glass rings, which are glass circles with the same center, as well as triangular prisms, and together these two things concentrate the light in a powerful beam that can go for over 20 miles. Fresnel's paper on diffraction won him the Grand Prix from the Académie des Sciences, which is the Academy of Science, in 1819. One of the judges, Siméon Denis Poisson, said his theory meant there should be a light spot in the center of a shadow cast by a round object, and when another scientist proved that that was actually the case, the committee took it as confirmation of Fresnel's work. Fresnel became a member of the Académie des Sciences and the Royal Society of London, both of which are very prestigious. He won the Rumford Medal for his contributions in wave theory and optics the same year that he died. He perished of tuberculosis at age 39. He remained religious throughout his life and said discovering the truth was more important to him than becoming famous. Even though we now use the quantum theory of light, which says light sometimes behaves as a particle and other times as a wave, Fresnel's work helped advance the undulatory theory and give us new insight into light and its properties. And since it inspired modern lighthouse technology, it also saved many lives along the way.